Hey guys, Dr. Jim Carmichael here. Let's run through the alveolar gas equation. While the equation itself is rote memorization, if you understand the physiology, it will help you keep it in your head. The alveolar gas equation was created to tell you the pressure of oxygen in millimeters mercury in the alveoli. Remember that the alveolar air we're talking about is the capital A, not the lowercase a. The lowercase a refers to the gas inside the artery. So how would we determine what's the amount of oxygen in the alveoli? First off, you're going to have to take what you're breathing in. This is the PiO2. It refers to the amount of oxygen coming in what you're breathing. Now, things are going to happen to that air. First off, your body's going to turn the water in the air into water vapor, which is going to take a small amount of the partial pressure up. And then, and this is the big one, once it gets to the alveoli, the gas exchange is going to be going on continuously. This isn't a swap where two people swap packages. This is more like a giant game of dodgeball where one team is throwing oxygen and the other team is throwing CO2, and it's going back and forth and back and forth. And then all your breathing does is try to clean up that mess and keep it moving. You're going to have to subtract the partial pressure of carbon dioxide divided by the respiratory quotient from the inspired oxygen to get the partial pressure of oxygen in the alveolus. All you need to know about the respiratory quotient is it's the ratio of carbon dioxide produced to the amount of oxygen consumed, and is normally assumed to be 0.8. Now you have the full equation. Alveolar pressure is equal to the pressure of oxygen inspired minus the arterial pressure of carbon dioxide divided by the respiratory quotient. Now you have the alveolar pressure. What are you going to do with this number? Well, remember, with this you can now get big A to little a gradient, or AA gradient. This is the alveolar oxygen minus the arterial oxygen pressure, and the range is normally 10 to 15 millimeters mercury. If that number goes up, there's a problem getting the oxygen from the alveoli into the blood. And you can see this in things like shunting, VQ mismatch, fibrosis, and other problems of the lung. That's it for this lecture, guys. Let's get you to the next one.